Hello guys, so in this video we will answer numerous kinds of problems in calculus, like finding the first and second derivatives. We have also applying the product rule to functions with exponential and polynomial terms. We have to also calculate the instantaneous rate of changes in real world scenarios like the motion of the cars and understanding cost functions. And we also have to evaluate indefinite integrals. So these topics overall were my chosen items from our problem set, and I will be discussing and answering those items using my tablet. And I will just paste the screen record of these tablets to the video. So without further ado, let's start. So for our first example, our first problem, we have the derivative. We need to find the derivative of the following function. And our function expressed by f of x is equals to sine raised to negative 1 half x. Our first task is to find the derivative of f of x is equals to sine raised to negative 1 half x. To do this, we will use the formula for the derivative of the inverse sine function, which is d over dx sine negative 1 u equals to 1 multiplied by du over dx. Here, our u is this one here. Our u is 1 half x. Let's compute the derivative of our u. We need to compute the derivative of our u for us to get the value of this one. And the derivative of 1 half x is 1 half. And after we get the derivative of 1 half x, we substitute the value of our u now into the formula, which then we will write it as f of x 1 over square root of 1 minus our u is this one, 1 half x squared multiplied by the derivative of our u, which is 1 half. 1 half. There. From here, we need to simplify. What is the square root of 1 half x squared? We get 1. Hold on. One half x squared is equals to x squared over 4. Let's substitute this into the solution we have earlier. We have x squared over 4 multiplied by u. And from here, we will solve for the denominator again. Let's further simplify. We have 1 over Let's simplify further the denominator. We have 4 minus x squared over 4 1/2. And from here, continue it as four x squared over. We can distribute the radical sign to the numerator and denominator. And to further simplify this, after this, we will get 4 minus x squared over the square root of 4, which is 2. And now we have this denominator here and 1/2. We'll have 1/2 multiplied by 2 4x squared. We got this by doing this rule of division. We get the reciprocal of denominator and multiply it to the numerator. Therefore, we got this. Okay. Now that we settle this, we need to simplify the constant. And the constant here is the 2. So we need to cancel out 2, which gives us the final answer, which is 1 over square root of 4 minus x squared. Therefore, the derivative of our function f of x is equal to sine raised to negative 1. 1/2 x is 1 over square root of 4 minus x squared. For our first derivative, we will use the product rule. For our product rule, it can be expressed as d over dx. We have f multiplied by g. We have the derivative of our f, g, derivative of our f, our g plus our f, and now the derivative of our g. This is our product rule. Here, our u will let our f to be the two x 3 plus e, and our g is ex plus 6. You can use this here. This is our g. This is our g, and this is our f. First, let's compute the derivative of our f. F of x is equals to 2x3 plus e. The derivative of this is 3 times 2, we have 6 squared. Just that. Since e is a constant. And for our g, derivative of our g, ex plus 6, we have ex. The derivative of ex is ex itself, and 6 is a constant, so this is equal to 0. So now let's combine this to, let's substitute this to our formula here. So the value of f of x is 6x squared, and our g of x is equals to ex. Now let's go back to our original equation. F of x equals to no, this should be f lang. It's g f there. So for our f of x, we need to get the derivative of f, which is this g plus our f and the derivative of our g. Now let's substitute these value to our equation, which gives us our f of f, derivative of f is 6x squared, and our g is e raised to x plus 6 plus, let's just copy the sign, our f is 2x cubed plus e multiplied by the derivative of our g, which is e raised to x itself. And now from here we will expand each term. We use the basic, that's not basic, from here we use our algebra skills. Let's distribute this to this and this to this. This is distributive property. Therefore we get 6x squared ex plus 6, get 36. 6 and 6 is 36. X squared plus distribute the 2x cubed to 2e raised to x, get 2x cubed ex plus, copy the sign, we have our e in e here, we will get e raised to x. There have it. We have our first derivative of the function. Of x. And now to get our second derivative, we get the derivative of this function now. Second derivative. So our function now is f of derivative of f of x, our first derivative. We have 6x squared e raised to x plus 36x squared plus 2x cubed e raised to x plus e raised to x. We will get the second derivative of this function. Then we write to find the second derivative, we need to arrange the equation first to 2x cubed ex plus 6x squared e raised to x plus 36x squared plus ex. And now from here, we use the product rule. This can be expressed as
motor mo din, magkagaling ta upat ng motor?
Okay lang yun eh.
Ha?
Okay lang eh.
Una na mo! Magkagaling ta upat! Bakit mga ka mo?
6x squared e raised to x plus 2x cubed e raised to x. This answer here is for this term. And for this term, we also need to use the product rule.
Saka sunod na tayo sa motor siya. Okay lang.
Plus
Sakay yung motor siya. Ito rin ko mamata.
12x e raised to x plus 6x squared e raised to x. And after this, we need to differentiate 36x squared. And we can express it as
Ano ka, Jen?
plus
Una na mo! Di mo ito magkarga, anak!
72x. And for our last term, the derivative of this is just itself, since e is a constant.
Sige na! Punta ka niya! Ngayon mo. Daw.
Plus
Bakit ba yung...
e raised to x. That's for
Bato na!
our second derivative. There's no like terms here, so we just need to there's this pala. So first, let's combine like terms. Like 2x. Saman! Okay, ping mo. We have e raised to x plus 12x squared e raised to x plus 12x e raised to x plus 72x plus x. And that is our second derivative of our function. And now let us move on to number 3, which is the distance traveled. We need to solve for the instantaneous rate of change here. For this problem, we need to we need the instantaneous rate of change of our equation here. We have this. Instantaneous rate of change is simply the derivative of our function. Let's compute it. For this, let's put our original function equation 2040. So we need to get the instantaneous rate of change at 30, as at t is equal to 30. First, we need to derive first our given dt t squared plus 24t then we have 2t plus 24. And from here, since we already have the derivative of our given, we need to substitute the value of t, which is 30, this value here, into this answer, this new equation that we got. Our t is 30. Let me change it. 30 to 30 plus 24, and with this 30, we got 3060 t plus 24. Then we have our answer, which is 84 feet per second. That's it. This is our instantaneous rate of change. Instantaneous rate of change at t is equals to 30. Remember, when we are talking about the instantaneous rate of change, or the word instantaneous, we need to get the derivative of our given function, and after that substitute the value of whatever that is given. Okay, let's move on to our item 4 here. A manufacturer cost function is given by c x 0.25x cubed minus 3x squared plus 20x, where x denotes its output level. Production is increasing at the rate of 5 per month. If the current output level is 50, how fast is the costing increase? Here we're tasked to find how fast the cost is increasing. The function is c of x is equals to 0.25 x cubed minus 3x squared plus 20x, and x is increasing at dx over dt equals to 5. Let's compute dc over dt using the chain rule. This can be expressed as dc over dt equals to dc over dx multiplied by dx over dt. And from here Let's differentiate c of x. 0.25x cubed. Cx equals to 0.25 x cubed minus 3x squared plus 20x. Let's get its derivative. We have 0.75x squared minus 6x plus 20. And now from here, as our x is 50, is expressed as the current output level is 50. Therefore, our x is equals to 50. Is equals to 50. And now that we got the derivative of our function, we substitute the value of x to the arrived or the answer that we got. Cx, no, it's not x. It's 50 equals to 0.75 50 squared 0.75 2,500 300 plus 20 0.75 multiplied by 2,500, we have 1,875 minus 300 plus 20. We got 1,595. Our problem here requires us to has a given that production is increasing at the rate of 5 per month. Now we multiply the our dx over dt is equals to 5 according to the problem. And now with that, we multiply the 5 into this answer we got here. dc over dt is equals to 1595 multiplied by 5. And there we have 7975 units per month. And that is our answer for problem number 5. And for our last item, we have to evaluate the following indefinite integral. Let's evaluate the integral 3x cubed squared minus 4x raised to negative 3 dx. To do this, we will integrate each term separately using the power rule for integration. It can be written as xn dx is equals to xn plus 1 n plus 1 over n plus 1 plus c. Now let's start with 3x squared with our first term 3x squared. Have 3x squared dx. This is equals to 3x 2 plus 1 over 2 plus 1. For resolve this, we got 3 x cubed, then 3 cancel, have 3. Next, let's integrate negative 4x. And now let's integrate the second term, which is negative 4x raised to negative 3. We have negative 4x raised to negative 3 dx. This is equals to negative 4. Let's refer to our formula, which is this one, to our rule of integration. Then x negative 3 plus 1 over if the denominator, our denominator is equals to the exponent of our numerator, negative 3 plus 1. Let's further solve this. Negative 4x negative 2 over negative 2. This we have negative, we got 2x negative 2 raised to negative 2. And as we already solved each term, let's combine terms by adding the results together. Three x squared minus 4x raised to negative 3 dx is equals to x cubed plus 2x raised to negative 2 plus c, our constant, which is this one. And that is the final answer. That is our final answer because we don't have any like terms to simplify or to combine. This is our answer to the equation here. Yes, I hope you learned something from this video, and I hope to see you again next time. And that is for integral a problem solving which involves getting the derivatives of our functions, the simultaneous rate of change, first and second derivatives, and getting the first derivative of a function. That's it for our session today. Thank you for listening.